Hello everyone, Katha Vaachak, the AI storyteller. Imagine a world where stories come alive at your command. Katha Vaachak is an AI-powered tool that lets users to create personalized stories based on their ideas. It leverages cutting-edge generative AI technology to create unique narratives. Today we will walk through the core aspects of the project, its applications, and the future scope. The Kathavasak AI storytelling tool provides a personalized storytelling experience through four main steps. User input. Users provide creative details such as character names, settings, and plot ideas. AI generation. The AI engine processes this input to create a unique and cohesive story, blending elements seamlessly. Storytelling. Users receive the custom story which they can read, share, or further develop. The AI can also generate accompanying illustrations for visual urban. Image generation. Using stable diffusion to create images based on character descriptions, adding a vivid visual dimension to the story. Key features of benefits. Customization. Users tailor stories to their preferences. Interactivity. The tool offers an engaging hands-on storytelling experience. Creativity. It supports creative exploration, allowing users to bring their story ideas to life. The tech stack for Katawachak project includes Mon Stack for building the web application interface and backend. Authentication and user management. You manage user access and profiles. Llama 2 for AI-driven story generation. Stable diffusion for generating images that accompany stories. Google Colab for model training and experimentation. Hugging Face for accessing pre-trained models and deploying AI. Kaggle for data sourcing and model training. Workflow. Users input plot Users take input plot, characters, and story settings. Kathawachak's GenAI code generates a story. AI generation refines the story based on inputs. Stable diffusion generates images, the story, and visual as presented to the user. Users provide feedback for further improvements. And coming to tech stack, Mon stack for web application, Mon includes four popular key technologies like MongoDB, ExpressJS, React.js, and Node.js. MongoDB for NoSQL database to store data. ExpressJS, a web application framework for Node.js that simplifies the creation of scalable APIs. React, a JavaScript library for building responsive and interactive user interfaces. Node.js, a server-side JavaScript runtime environment that facilitates server-side operations. Llama 2, Llama 2 for story generation, an advanced large language model developed by Meta. Llama 2 can take user inputs like character details, settings, and plot elements to generate unique coherent narratives. Stable diffusion for image generation. Stable diffusion is a deep learning model used for generation high quality images from textual descriptions. In Katha it can enhance the storytelling experience by creating visuals that accompany generated stories. Together, the Munchstack Llama 2 and Stable Diffusion create a powerful interactive storytelling platform that allows users to generate both narrative and visual elements, resulting in a fully customized and immersive experience. This combination of technologies ensures scalability, flexibility, and responsive user experience across the device. The Kathavacha project targets on following audiences: children, for providing interactive way to children to explore storytelling. Writers offers a tool for brainstorming story ideas and generating new narratives. Storytelling enthusiasts, appealing to anyone who enjoys creating and sharing stories. Applications: bedtime stories, creative writings, educational use. Future scope: multi-language support, expanding allow story creation in various languages, voice interaction, and advanced AI. LLMs, large language models. These are powerful area models trained on exhaustive datasets consisting of text and code. The fundamental capability of LLMs lies in their ability to understand and generate human-like language by recognizing patterns in vast amount of data. Generative AI refers to ability of the models to produce creative outputs. The model can generate various forms of text, like poems, codes, script, emails, letters, etc. Essentially, the AI generates content based on the input it receives from the user, making it versatile tool for content creation. Katha Vaachak. This specific tool uses LLM to compare user input and generate the engaging stories or other types of textbook based content. The goal here is likely to create stories that are both coherent and captivating based on user provided prompts. The user input, how it all works. The user provides input. The LLM analyzes the input utilizing the vast training in language. The generative AI outputs creative content that matches the input requirements, producing text in various forms such as story or code snippet. Llama 2 training. Llama 2 model is a pre-trained on an existing dataset consist of text and code. Pre-training means the model is initially exposed to a broad and generative generalized dataset, allowing it to learn patterns in language. This phase equips the model with a baseline understanding of general language tasks, but it's not yet specialized in any specific domain. Fine-tuning. Specialization for story generation. After the initial pre-training, fine-tuning is conducted. During the fine-tuning, the pre-trained Llama 2 model is exposed to more specific dataset, in this case dataset of story narratives. The goal here is to specialize the model in generative stories. By providing narrative specific data, the model learns about the story structure, character development, dialogue, and plot progression, etc. Fine-tuning is crucial because it narrows the model's focus to particular domain like storytelling, making it more proficient and capable to area. Quantization. Generally, we need quantization to optimize for efficiency. Once the model has pre-trained and fine-tuned, it undergoes quantization. Quantization is a technique used to optimize the model, focusing on reducing the size of the model to make it more efficient. This involves compressing the model in a way that is requires less computational power and memory without losing significant accuracy. Quantizing a model helps improve its performance in real-world application, making it faster and more resource efficient while still maintaining the ability to generate high quality stories. The overall aim of this process is to create highly optimized and specialized Llama 2 based model that can generate engaging and coherent stories while being computationally efficient. By combining pre-training, fine-tuning, and quantization, the model becomes both powerful in generating narratives and optimized for practical use. And that's all for today. Thank you. And next we will focus story generation part is completely completed. Next we will concentrate on image generation using stable diffusion.